Hi, this is King of Review. So we have a log function here with a base that we're not sure about yet, and we need to find the range of real numbers a to plug into this base so that if x1 is less than x2, f of x1 is less than f of x2 for any real numbers x1 and x2. It'll be helpful here to think about what logarithmic functions tend to look like. As long as the base, this a squared minus 2a plus 2, as long as the base is greater than 1, then when you raise a number greater than 1 to a higher exponent, it will produce a higher number. So generally logarithmic graphs look something like this. And the important thing to notice about this graph is that it is already increasing. From left to right, as x moves from left to right, y moves from bottom to top. That's exactly what our two conditions say. If x number 1 is less than x number 2, so maybe here's x1 and here's x2, then we want f of x1 to be less than f of x2. Well, if we follow x1 up, it looks like right around here is f of x1, and if we follow x2 up to the graph, somewhere around here is f of x2. So we can see that since x1 is less than since x1 is less than x2, f of x1 is also below f of x2. It is less than f of x2. So these two conditions basically mean that we want our graph to be increasing, and that is true for any logarithmic graph as long as the base is greater than 1. So if we want to find the range of numbers a that make this condition true, all we need to do is say, okay, the base a squared minus 2a plus 2 must be greater than 1. So let's see if we can solve this. If we subtract 1 on both sides to make the right side 0, often when we have an equation with an exponent of 2, we want it to be equal to 0. So let's see, that'll give us a squared minus 2a plus 1 is greater than 1 minus 1 is 0. But this is very nice, because this left side factors. It factors it into a perfect square. A minus 1 squared is greater than 0. And that's because if you do a minus 1 squared, that's the same thing as doing a minus 1 times a minus 1. If we use the distributive property, we distribute a times a is a squared, a times negative 1 is negative a. And then if we distribute negative 1, we have negative 1 times a is negative a. Negative 1 times negative 1 is positive 1. Combining the two like terms gives us a squared minus 2a plus 1, which is exactly what we started with. So, we know that it can factor into a minus 1 squared, and that has to be greater than 0. But remember, any number that you square will automatically be greater than 0 unless it's equal to 0. The graph of a function y equals x squared is a parabola with a minimum at 0. It's always a positive number, a number greater than 0, unless it's 0. So a can be any real number, since any real number, when you plug it in to this equation and square it, will be positive, except we don't want it to be 0. We have greater than 0. We don't want it to actually equal 0. So we don't want a minus 1 to equal 0, and if we add 1 to both sides, that tells us we don't want a equal to 1. So a can be any number except 1, because if a were 1, we would get 0 for this equation, and we want it to be greater than 0, not equal to 0. So that gives us an answer choice of a, any real number except for 1. And that's it. Thanks for watching.